Hello children, in the previous video we had a very short introduction into what is arithmetic progression. Now here let us see some examples. Let us see a list of numbers which are given to us and conclude whether they are arithmetic progressions or not. Working out these examples will give us more clarity on this topic. So the first example, let's take 0, -4, -8, -12 and so on. We'll have to check whether it's an arithmetic progression or not. We've seen that in an arithmetic progression, if these terms can be called as A1, A2, A3, A4 and so on, the difference between the consecutive terms, which is A2 minus A1 should be equal to A3 minus A2 and it should be equal to A4 minus A3, etc. That is, there should be a common difference. It should be a common difference. The difference should not be different. It should be same. Right? So let's check this first example of ours. What is the difference? Let's do A2 minus A1 first, which is -4 minus 0. It gives us -4. And A3 minus A2 is -8 minus of -4, which is -8 plus 4. This is also equal to -4. The difference is the same. Let me check for the next term, next consecutive term also, which is A4 minus A3, which is -12 minus of -8, which is also -12 plus 8, so -4. The common difference is the same, so we can safely conclude yes, this is an arithmetic progression. Okay, but let's remember that even if we can say that one of these differences are not equal, suppose the first term was -4 and the second the difference was -5 or 6 or whatever, we can immediately conclude that it's not an arithmetic progression. But in order to say that it's an AP, we'll have to check for every term, every consecutive term, the difference has to be the same. Of course, sometimes it becomes impossible to check every consecutive term, especially when the list of numbers which are given to us are very long. That is why we start coining the general form by recognizing the pattern. If you will be able to write the general form of the sequence, then we can safely conclude that it's an arithmetic progression. Anyway, we'll see that in our upcoming videos. Now, let us just do these examples. Next one would be another sequence, another list of numbers which is given to us. We'll have to decide whether it is an arithmetic progression or not. So it's 2, 5 by 2, 3, 7 by 2 and so on. So it's an integer, a fraction, an integer, a fraction. So now how do we go about it? Let's look at these two fractions. They are actually improper fractions, right? They can be changed into mixed numbers. How do we go about that? If you divide 5 by 2, you get 2 2s are 4 and 1 is the remainder. So this can be 5 by 2 can be written as 2.5, isn't it? 2.5. One more way of looking at this is, if you have 5 things, let me call these bread slices, okay? And I have to make sandwiches, so let me pair it into 2 of each. So with 2 bread slices, I can make 1 sandwich, and with these 2, I can make another. And now what is left? 1 of 2. Just 1 piece of bread of the 2 which we wanted. We are dividing it into pairs of 2, right? So just 1 piece is left, so we can say 2 pairs of the bread in order to make a sandwich and a half is left. This is how we normally look at fractions in our earlier school ages, right? So 2, 2 and 2.5. And what is 7 by 2? 7 by 2, you can just straight away divide if you find that easier. It gives you 2 3s are 6 and 1 is the remainder, which is 3.5. So 7 by 2 is 3.5. Now look at the sequence. Let me fill the gaps. 2, 2.5, 3, 3.5 and so on. So your common difference is half. So since the common difference, let me call the common difference as d. If d is equal to half, then I can safely conclude that yes, it is an arithmetic progression, right? It is an arithmetic progression. So just one more example. Let's have these decimals, negative decimals, minus 1.2, minus 3.2, minus 5.2, minus 7.2. So in order to decide whether it's an arithmetic progression or not, let us just check the difference. So A2 minus A1 would be what? Let me do the calculations here. Minus 3.2 minus of minus 1.2 would be plus 1.2. What is the difference? 2 minus 2 is 0, a decimal, and 3 minus 1 is 2. So the difference is 2. That is, if you add 2, if you add 2 to this, you get the next term. And let me check the A3 minus A2 also. It is minus 5.2 minus of minus, which is 3.2. Here also we get the same difference, minus 5 and 3. Okay, it's a negative 2 because 3.2 is bigger and it has a negative sign attached to it. So our common difference is not positive 2, it's a negative 2, right? So let me change it to negative 2. So here also the difference is the same, so negative 2 and so on. Since the difference is d is always minus 2, we can conclude that the third example is also an arithmetic progression. Yes, it is also an arithmetic progression. Now, just one more example, the fourth one. Again we have a decimal 0.2, 0.22, 0.222 and 0.2222. Of course, there is some pattern here, but we'll have to check whether it's an arithmetic progression or not. That is, we'll have to see if the common difference is the same. So let's start subtracting A2 minus A1. Decimal subtractions are always tricky, so it is always safer to write it down and subtract like this. So 0.2, since the we need two decimal places, so let me put a 0 there. 2 minus 0, 0, 2 minus 2, sorry, once again I am making a mistake. 2 minus 0 is 2. 2, 2 minus 2, 0, so 0.02, right? So this is our difference. And what about the next one? 0.222 minus 0.220, right? So 2 minus 0, 2. This is also 0. The next 2 minus 2, the 1/10th place is also 0. So 0.002. See, the difference is already not the same. So even if one term differs, we need not go and check the other term. So we can safely conclude that no, this is not an arithmetic progression. This is not an arithmetic progression, right? I hope you followed, and in our next video, let us try to arrive at this general form. And I hope you understood till now. Thank you.